Hey, this is Mrs. Davis. This is lesson 610, Calculus, Integrating with Long Division and Completing a Square. We're on our third video, and we're looking at the very last technique we're going to use, which is long division. So always try to talk about how you know what to use when. And so let's talk about this problem here. At first look, maybe I could let u equal x squared. Because I have an x here, so I say, okay, du would then be 2x dx. So dx is du over 2x. Well, this is on the bottom, and so is this, so that does not get rid of my, my x. So that's not going to work. And so what we do is we look at this again and we say, the degree on the top is one larger than the degree on the bottom. So why don't I rewrite this as a, why don't I actually divide this out and get a polynomial with a remainder? And then maybe I can integrate each piece. So that's the idea. All right, so we're going to do long division. It's not going to take us long. This is a refresher here. We have x squared plus 0x plus 0. Remember, we have to have all three of our terms if we're doing. We have to make up the 0 ones to make this division come out right. So you say, okay, what times x gives me x squared? So it'd be at x. And then I multiply these two together. That's x squared minus x. And don't forget, you're subtracting the whole thing. So you have x squared minus x squared here, which would be 0. And you have 0x minus a negative x. So that would be plus an x. So you have x plus 0. And then what times x here, again, would give me x. So I would have plus 1. Now my remainder is going to matter. So when I do 1 times x minus 1, I get x minus 1. And I'm subtracting that. So the x's go away, and I have 0 minus negative 1. So I have a remainder of 1. So when you long divide, that would be rewriting it as x plus 1 over x minus 1. Remember, you always put it over your divisor. So let me highlight that right here. So now I'm just going to integrate that. See, those are the same things. These are identical. I just have rewritten it like that. After dividing. So now I can split it up. So I can say this is the integral of x dx plus the integral of 1 dx plus the integral of 1 over x minus 1. dx. All right, so each one of these, I don't need to use u substitution, I don't believe. First one would be 1/2 x squared plus the integral of 1x dx is x plus 1 over x minus 1 is ln of absolute value of x minus 1 plus c. Now you could have used u substitution for this because we know that 1 over u du is ln absolute value of u. But you can also know that this would come out to be the same because the the x is taking the derivative of x would be 1. But I'll show you so you can see. This would be let u equal x minus 1, so du is dx. So you would rewrite that as the integral of 1 over u du. And that would be ln, absolute value of u, right, plus c. Sorry, and then that would be ln of x minus 1 plus c. And the reason it comes out is because the derivative of this inside is just 1. So it's really, you didn't have to do a chain rule for that. All right, so that is the answer to that problem. And so actually, very easy once I did long division. All right, let's go on to, I zoomed way in. Let's go on to example 5 in your notes. So I have x cubed plus 5x plus 10 over an x squared. So I can tell I'm not going to be able to use u substitution until maybe I change this around. So I'm going to do long division. So I have x squared plus, now look, I have to have every term. So I'm missing 0x plus 1 divided by x cubed plus 0x squared plus 5x plus 10. So don't forget, you have to put all those terms in if any of them are missing. Now, x squared times what gives me x cubed? It would be x. So then when I multiply x by this, I get x cubed plus 0x plus x. Okay, I got to make sure I'm doing this right. Now, I'm going to subtract. So we would get 0 for the x cubed minus x cubed. 0x squared minus 0x squared is just going to be 0x squared. And then 5x minus x would be plus 4x. And then I bring down my 10. All right, now when I go on, I get 0x here. So this would be x squared times what gives me 0x squared. So this has to be plus 0. And so then I would get 0x squared plus 0x, and you end up with 4x plus 10 as your remainder. So rewriting this, it's x, and I'll just leave out the plus 0, right? Plus 4x plus 10 over x squared plus 1. Now I'm going to divide these two terms up here. And so this was the whole big thing, but now let's make it pieces. So x dx plus integral of 4x over x squared plus 1 plus dx plus the integral of 10 over x squared plus 1. Okay, and so let's let u be x squared plus 1. So du equals 2x dx. So dx is du over 2x. So that's going to help me with the second one. This one becomes 1/2 x squared. Now this one has changed to, we can cross out our 2x and our 4x, leaving me a 2, 1 over u du, plus, look what this is. This is, isn't that an inverse tan? If I take out a 10 and the integral of 1 over x squared plus 1 dx. So I am good to go right now. I have 1/2 x squared plus 2 ln the absolute value of u plus 10 inverse tan of u. Oh no, just x. I didn't have to use substitution for that. Plus c. So the only thing I have to substitute back in is this u. So I have 1/2 x squared plus 2 ln of the absolute value of x squared plus 1 plus 10 inverse tan plus c. Yay! There we go. Now remember, each one of these would have a plus c, plus c, plus c. But if you add c plus c plus c, it's still going to be c. All right, it's just a constant, and so it's just a different constant, but c is c. All right, so I'll stop that video here.